Okay, so on our next page, we have a method for balancing our equations, okay? So this is a skill that we're going to work on, and this is getting us up to that level 3, is being able to balance our chemical equations, okay? So our first step, right, we're going to draw a line to separate the products from the reactants. So let's go down to our example here. We're going to separate our products and our reactants. I'm going to put a line up top here as well, just because that is the chemical equation that we want to get to. All right, we're going to list each of our different elements on each side of the line. So we're going to have hydrogen and oxygen. We got hydrogen and oxygen on the right-hand side. We're going to count up the number of atoms on each side and record it next to the element symbol. Well, on this side, I have 2 hydrogens, and I have 2 oxygens. And then on this side, I have 2 hydrogens again, but only 1 oxygen, okay? So now this is where we need to balance, okay? So we're going to find the most complex compound in the equation, balance the elements found in that compound on the opposite side of the arrow by changing the coefficients for the different species. Every time we change a coefficient, you must update the number of each element. Okay, so let's look at our most complex. That would be H2O, right? It's got hydrogen and oxygen in it. I need to balance our number of hydrogens and oxygens. Well, I have 2 oxygens over here, so I'm going to need to multiply this by 2. So let's put a 2 there, right? I put a 2 up there. Well, that means that I have 2 oxygens, and that means I have 4 hydrogens, okay? So now I have 2 times 2, 4 hydrogens, 2 times 1, 2 oxygens. My oxygens are balanced, but now my hydrogens are not. How can I make my hydrogens balanced? Well, I need to have 4 of them. For me to get to 4, I'm going to need to multiply this by 2, and I get to 4 there, okay? So now, right, we check our answer at the end. We have 2 times 2 is 4 hydrogens. I have a 1 times 2, that's 2 oxygens. And then let's check our right-hand side. 2 times 2 is 4 hydrogens, and 2 times 1 is 2 oxygens. So I have the same number of each element on both sides. Okay? Let's check another example here. Okay? This one is Na plus H2O goes to NaOH and H2. First step again, we're going to separate our 2 sides. We have Na, hydrogen, and oxygen. So sodium, hydrogen, and oxygen, and I've got the same over on the right-hand side. So that's good. I'm going to put them in the same order. On my left-hand side, I've only got 1 sodium, I've got 2 hydrogens, and 1 oxygen. Okay, now let's look at the right-hand side. I have 1 sodium, 1 oxygen, and 3 hydrogens. That seems unbalanced. So let's now find the most complex, okay? This is definitely my most complex compound, right? My most complex species because it's got all of my elements in it. So if I notice here, I've got an odd number of hydrogens right now because I've got an odd number of sodium hydroxides. Well, so let me double that up. If I double that, well, that means that I've got 2 sodiums. I've got 2 hydrogens plus 2 more there. That's going to be 4 hydrogens and 2 oxygens. 2 oxygens. Okay, so now I've got a even number of my hydrogens, so that is going to be a little bit easier because I have an even number of hydrogens in my water. Well, let's look and try and balance this now. To get my 4 hydrogens, I'm going to need to double this. So that makes 4 hydrogens, and 2 times 1, that makes 2 oxygens. So that is balanced. Our oxygen is balanced. Let's get our sodium balanced here, right? There's 2 sodiums at the end, so that makes that 2, and that leaves that at a 1. You'll notice, right, that I balanced sodium pretty much at the end here because sodium is really easy to balance. I can just have however many multiples of sodium there, okay? So start with our most complex, end with our least complex, okay? Let's do one more example here. We've got CO2 and H2O goes to C6H12O6 and O2. What type of reaction is this? This is the opposite of a combustion reaction. The opposite of a combustion reaction, right? This is making sugar, right? Plants do this, okay? So we may know that from our biology, okay? But now let's look at this, right? We're going to split it into two. We have carbon, oxygen, and hydrogen here. So carbon, oxygen, and hydrogen. Carbon, oxygen, and hydrogen, okay? So what we are going to do to help us balance this equation, oxygen is definitely our least complex. We'll balance that. We'll balance that at the end. Our sugar molecule here, C6H12O6, that's definitely our most complex. So how many? Let's count each of these, and we're going to start when we're balancing with our sugar. Okay. So right now I've got, well, just one carbon. Oxygen, I've got 1, 2 there, plus 1 there. That's 3. And hydrogen, I've got just 2. Okay. Over on the right-hand side, I've got 6 carbons. I've got 12 hydrogens. Whoops. 12 hydrogens, and 6 plus 2, that's 8 oxygens, okay? So, a little bit weird here. What I'm going to recommend is we start with our carbons. Let's start with carbon, because that's our first one that we listed. We've got 6 carbons there. So, we're going to need to put a 6 over here, and when I do that, that's going to get me my 6 carbons. That's good, but it also changed my oxygen. So let's change our oxygens. So 6 times 2 is 12. Plus 1 is 13. That doesn't seem very good. Now I notice, well, let's check my hydrogens. Hydrogen, I've got 12 over on this side and only 2 there. So let's try and balance that. Well, I need to have 6 there as well. If I do that, that changes my hydrogens up to 12. That's good. Now my oxygens, I've got 6 times 2 is 12, plus 6 times 1, that's 12 plus 6, that should be 18 oxygens on the left-hand side. So now you notice all of the numbers on my left-hand side are the same or equal. So now I'm going to go back to the right-hand side. Well, I left this as a 1, so I've got 1 C6H12O6, and then how many oxygens do I need? I need to get up to 18. I've got 6 in this formula, so I need to get 12 more over in this side. 12 more, to get me to 12, I'm going to need 6 oxygens. That should, right, 1 times 6 plus 6 times 2 is going to be my 18. So now my carbons, my oxygens, and my hydrogens are all balanced, okay? One last piece with this. One last note. When we balance our chemical equations, polyatomics can actually be balanced as a unit. Polyatomic ions may be balanced as a unit, as a whole piece, okay, rather than as separate elements, as long as they stay intact, right? So our example here, we've got Al2SO4, right? But the SO4 stays intact and is the sulfate over on the right side. The hydroxide here, calcium hydroxide, stays as hydroxide on the right-hand side. They remain intact. They're going to stay the same. This is why we need to know our polyatomics. So, right, we can think of sulfate as a whole big unit and the subscript of 3, so that we have 3 sulfates on the reactant side and 1 sulfate on the right-hand side. Okay, so let's balance this equation, right? We're going to split it in half. We're going to have aluminum and sulfate, SO4 2-, calcium, and hydroxide, OH1-. Let's put the same over on the right-hand side. Al, SO4 2-, Ca, and OH-. Aluminum we know is a +3, so that should be an uncharged formula. That's good. Calcium should be a +2, so that's an uncharged formula. So We don't need to worry about our ionic compounds. We don't need to worry about our subscripts at all. Let's just worry about balancing our reaction. Okay, so over on the left-hand side, I see that I have 2 aluminums, I have 3 sulfates, I have 1 calcium, and 2 hydroxides. On my right-hand side, I've got 1 aluminum, I've got 1 sulfate, 1 calcium, and 3 hydroxides. Okay? So what I'm going to look at here is I'm just going to go down my list. This is a double replacement reaction, so I can just go down the list, and everything should balance out. So let's look at aluminum. Well, I've got 2 over on this side, so I need 2 over here. So I'm going to put a 2 there. That changed my aluminum. That's a 2, and it changed my hydroxides. Now I have 6. Okay? Now let's look at my sulfates. I've got 3 on this side. Well, I need 3 on this side, so I'm going to put a 3 over on the right-hand side. That changes my sulfates up to 3 sulfates. It also changes my calciums to have 3 calciums. Now let's come back over to the the left-hand side. I said that I have my aluminums balanced, I have my sulfates balanced. My calciums are not balanced. I only have 1 on the left-hand side and 3 on the right. So I need to put a 3 here. That changes my calciums to 3. And how many hydroxides now? 3 times 2, that's 6 hydroxides. All of my numbers match up. My equation is balanced. Okay? We're going to get some practice with this.